Today, we're going to pull back the curtain on the hidden engine that powers, well, pretty much everything you buy. It's a system so incredibly efficient, it's built around a totally wild idea. What if the best way to run a warehouse was to not store anything at all?
I mean, really think about it. You walk into a giant home improvement store. How does that insane variety of products, everything from 2x4s to tiny light bulbs, magically show up on the shelves day after day? You have to wonder, where on earth do they keep it all? You're probably picturing some colossal warehouse out back, just stacked to the rafters with inventory. But the real secret, the actual genius behind modern logistics, is a building designed to do the exact opposite, to hold almost nothing for almost no time. To really get why this system even exists, we have to start with the problem it was built to solve. And trust me, it's a huge one. The absolutely massive cost of just moving stuff from A to B. Okay, here's the crucial detail, the number that changes everything. Sending a truck that's only half full, what the pros call a less than truckload or LTL shipment, costs nearly twice as much per item as sending a completely full truck. That simple fact creates this huge financial incentive to make sure every single truck hitting the road is packed to the gills.
And the solution to that really expensive LTL problem is a totally different kind of building. See, it's not designed for storage at all. It's designed for pure, unadulterated speed.
It's called a cross-dock, and I want you to forget everything you think you know about a warehouse. In a cross-dock, products arrive, they get sorted, and they leave on another truck almost immediately. We're talking a matter of hours. The goal here is zero storage time. Honestly, the best way to picture it is like Grand Central Station, but for freight. Pallets and boxes don't come here to rest. No way. They come here to switch trains, or, trucks, and get to where they're going as fast as humanly possible. And the process itself is this beautiful, simple dance. It's incredibly fast. Goods are unloaded from maybe dozens of incoming trucks. They're immediately sorted right there on the floor based on what store they're going to. Then they're moved straight across the dock and loaded onto brand new and now completely full trucks heading out. So that's the theory. But what does this look like in the real world? Well, let's check out a company that has totally mastered this process on an unbelievable scale. You're not going to believe this, but the Home Depot is the single biggest user of that expensive LTL shipping in all of North America. So for a company that size, this isn't just some minor issue. It's a multi-million-dollar puzzle they have to solve every single day. And this just perfectly illustrates their genius solution. Instead of having 100 different vendors, each send a tiny, expensive, half-empty shipment to one store, they have those vendors send full trucks with products for maybe 20 different stores to one central cross-dock. Then, everything gets sorted, and a new, full truck is built with everything that one specific store needs. It literally turns 100 expensive trips into one cheap, efficient one. And the savings? Oh, they are huge. Transportation costs just plummet. But it doesn't stop there. You need way less inventory, because goods are always on the move, and you need less labor, because you've basically eliminated the two most time-consuming jobs in a warehouse, putting stuff away and then trying to find it again later. So, if the whole point of this building is pure frictionless speed, how in the world do you design it? Well, it turns out the geometry is everything. This right here is the classic design, a long, skinny rectangle, sometimes called an I shape. And why? It's simple. It makes the distance from the incoming truck door on one side to the outgoing truck door on the other as short and as straight as possible. No wasted motion. And it turns out there's kind of a magic number for how wide these buildings are. It's almost always right around 120 feet. And that number isn't random at all. It is precisely engineered. 120 feet gives you just enough space to stage the freight as it comes off the trucks, while leaving two dedicated highways right down the middle for forklifts to fly back and forth. Any wider, and you're just adding travel time and cost for no reason. There's another key design rule, and it's based on a really simple fact. Carefully loading up a truck takes about twice as long as just quickly unloading one. So, to keep the whole system in perfect harmony, for every one door you have for incoming trucks, you need two doors for outgoing trucks. So you're probably thinking, okay, why not just build them bigger, with way more doors? Well, here's the catch, and it's a big one. The bigger the dock, the worse the traffic jam gets in the middle. The congestion doesn't just double, it can literally quadruple, creating this massive bottleneck right where you need speed the most. And that brings us to the biggest challenge in crossdock design, the #1 enemy of efficiency: corners. I mean, just look at this. On the left, you've got that clean, simple, efficient I shape. But what happens when you add just one corner, like in that L shape on the right? You can almost feel the slowdown, right? That one little corner creates a huge headache in two different ways. Okay, so an outside corner, that actually cuts down on the amount of floor space you have right by the door, which means freight gets piled up and causes a traffic jam. Meanwhile, an inside corner is even worse. You can't even park trucks there without them bumping into each other, so you lose super valuable door space and you force all the other forklifts to drive a longer way around. So this is the big trade-off. The straight I shape, that's the king of efficiency, hands down. L and U shapes, they just add those awful corners for basically no benefit. But T or X shapes are an interesting compromise. Yeah, you get the corner problems, but you shrink the maximum distance a forklift has to travel, which in a truly massive building can actually be a worthwhile trade. So the next time you're driving down the highway and you see one of those long, boring-looking buildings, you'll know the secret. It's not just a warehouse. It is a highly optimized machine where every single foot, every door, and every angle has been engineered for one thing and one thing only: moving stuff as fast as is humanly possible. And that leaves us with this really fascinating question for the future, right? In a world of same-day and even same-hour delivery, our demand for speed is just getting more and more intense. So how will the design of these simple but powerful buildings have to change to keep up?